Alright, so we're going to do a quick video on the ENIAC 40 and Klipper, and I'll put some links down in the description, go into more detail on exactly what Klipper is, and a lot of videos about reviews and how to set up basics of it. But this video is going to be specifically about Klipper and setting up Klipper for the ENIAC 40, and why different values are chosen, and why they're set up in certain ways. And so we're just going to go through in this video the config for Klipper, and the way it's currently set up, and we'll talk about some things that might change in the future as we go through the setup. So with that, let's get into it. As you can see here in the first portion, all we're doing is we're defining the X stepper, or stepper X, basically the pin that it's at, the direction that it's at, the enable pin, and then the step distance. There's again good videos talking about how to set up the step distance and why it's different, but there's on the wiki page talks about the formula for calculating step distance if you're coming from Repetier or Marlin. This 0.0125 is the value we use for the default steppers that are recommended in the ENIAC BOM. This is with the Trinamic driver set to step kick, I believe. Not the super silent one, which I think is stealth shot, or maybe the other way around. But it's set to the not silent one, so it still has all the torque and it's still quieter than the other drivers. But it's just the TMC 2100, not the 2130 either. Then as we go through, we have the end stop pin, and these are defined for now in the Arduino mapping, which we'll go over in a little bit, but you can use the native pin values, which you'll see as we get down in the description. The max position, just a regular Z max. Homing speed is actually set to pretty high intentionally. Right, there's no reason non-printing moves can move quite faster than 200, but the carriage actually slams into the XN stop at about 200 millimeters per second. It's pretty quick, and I'll post a video showing that later in the future. But it is pretty quick and more than sufficient to move the head from the max endpoints all the way to the homing in a few seconds. So no really reason to go any faster, and I think you could actually risk breaking the X end stop or the Y end stop if you go too fast. But the second homing speed is 50. That is actually the default for the homing speed, but we do is we home really fast and then back off a little bit and then home again at 50 millimeters per second. That still gives enough accuracy. I may drop this down even lower to 25 just to give a little more accuracy, but really the only time this really comes into true play is if you're doing maybe like a multi-part print where you're trying to print stuff on top of each other, or if you're resuming the print and you're homing in between that resume. Similar setup for the Y, and then we have the left Z stepper, and we call that just stepper Z. Similar configurations to before. Maximum is 415 in this case. This might change as it goes to the slice hot end, but right now it's 415. And then because of the probe, you want, just in case that for some reason the probe value is lower, then you want to have a minimum value of -4. You wouldn't do this with a mechanical end stop, but with a probe you kind of have to, just as you're running some of the calibrations. And again, an initial homing speed of 60 millimeters per second, just to bring the bed up really quick up to that initial Z0. And then it does the second homing speed at 2 millimeters per second, just to get that precision on the current inductive sensor that's on there. This will likely change as I get a better inductive sensor, but for now it does have to be pretty slow to ensure that repeatability, which is still not even that accurate, but it's good enough. Then we just have the right Z stepper. Klipper sees it as stepper Z1, and then we go through the rest of the pins on here. Same thing as before. You'll actually notice that, if I forget to point out here, it is called for the end stop for Z. It is called probe Z virtual end stop. So you can still use a probe, but use a mechanical end stop. In this case, I'm just using the probe as the end stop here. And then there's no need for a probe on the right or Z1. I have a custom thermistor table here, which takes 3 values. In my case, I just used kind of the range that I normally print at. I usually print at about 220 in PLA, so I just kind of went down to 100 and up to 300, and the resistance values from the B3 Pico. It's unfortunately it's not very accurate in the lower temperatures below 50, but I don't really care because I never print anything below 200 anyways, so it doesn't matter. As you go through the extruder, very similar settings before. You do have to define a nozzle diameter because of what Klipper calls advanced pressure, or pressure advanced, which I still haven't configured. And then the stepping distance is going to be based on the extruder you're using. So this was for the Titan with the normal Allegro 4988, but this may change or likely will change with the BMG. You have to define the filament diameter. I don't know why, but it's what it is. What it is. And then you're defining the custom sensor here for the B3 Pico. In this case, a custom pull resistor value. Again, these are not usually used if you're just using the standard costs whatever 100K thermistor that comes from everywhere else. Just some old values I played with, which probably deleted. The analog pin. And then the PID values you'll see here are commented out, and that's a particular reason. We'll touch on that towards the end. Your min temp, which I intentionally have set very low because of the B3 Pico's inaccuracy at lower temperatures, and my office does drop into about 50 C, about 50 Fahrenheit, which I think is about 15 or so C, and so the B3 Pico will read that sometimes as like -4 C, because again it's inaccurate at the low values. So I just had to drop this to -20. Max temp, I could probably go higher, but it's fine for now. And then we have the maximum extruder distance. This is important because of the filament loading and unloading macros that you'll see in a little bit. But that's really important there to have that 800 value. Otherwise, you will get extrusion over extrusion errors. And then minimum temperature for extrusion, just to make sure you don't extrude while the nozzle is still cold. Again, mostly I print PLA, so this 205 is fine. The heater bed settings. Now, this was set at watermark, which is similar to Bang Bang and Repetier and Marlin, but I actually did change it to PID because I was getting a lot of Z-banding. I was also getting Z-banding and Repetier, so it's not a firmware issue. It's just an issue of the thermo expansion of the actual heat bed. So this has to be set to PID. I do have a 120 volt heat bed. That is what we recommend. But you want to be careful that you only use this if you're using really good solid state relays, which is one of the reasons why we recommend the Opta 22 SSRs, and not a mechanic. Definitely do not do this if you're using a mechanical relay. You will fry and burn the mechanical relay. And if you're using an underpowered Chinese clone relay, like those grayish ones, probably not recommended either. You should just stick to Bang Bang or watermark here, and then deal with the Z-banding, or hopefully you have a really good plate and you don't have thermal expansion. But it was getting really bad thermal expansion, and after research and talking to a lot of people, if you have good relays like Opta 22s, then you can go to pit controller, and the bed does stay pretty consistent throughout the whole print. I thought I pit tuned the bed, but I guess I didn't. That's why it's not commented out here. And then you have the minimum temperatures, the maximum temperature for the bed. Maximum delta is only used in the watermark. Some people do set this down to 0.5 just to help keep it accurate, because remember, if you set this to, let's say your temperature 70, and your watermark is 1 like I have it here, what will end up happening is it'll go to 71, and then when it hits 72, it'll turn off, and then of course it's still going to heat up a little bit, so it'll get to 72.5, and then it'll cool down all the way to 69, and then when it hits 68 is when it'll actually turn on, but that cool down is still happening, so it'll hit 68.5. So you really have a pretty big swing, and so half is really recommended, but again, you have to be careful if you don't have good relays. The layer fan, just again, this is the AR7, the Arduino reference pin. This is where I mentioned that you can use the native, I think they're native ARM pins, or native microcontroller pin naming, PH5 in this case. I just, for sake of continuing the Arduino naming, I would just looked up the values for PH5 in the Marlin pin configuration. I think Repetier has it too, and then converted that to the AR7 that was listed there. Now again, this AR7 could just be changed to PH5, and it should be for Klipper. That is the recommended method, but again, this does work. Then I actually use the Roomba has a second fan, and so I used a second fan output. So I actually use that specifically for the heatsink fan, so that the heatsink fans are not always running. And I also use it for the 80 millimeter fan that cools the Roomba. This will also eventually be set to control the XY stepper fans too, since there's no reason for them to be running if the printer is not actually on. And then you just define it that when the heater extruder, right, so when your extruder temperature is over 30, that's when these fans kick on. This should be higher, closer to like 50. I just like setting it low when I'm testing to make sure that the fan's kicking on properly, and then I can just slowly raise this up to about 45, 50. Fan speed's just power on all the way, right? You can set this to half value if you need to, but that's fine. I just run the fans on full speed. This is that pin map I was talking about, right? Defining the pin map Arduino, you define the serial location of the board. Then we get to the kinematics. There's a lot of extra stuff here, and you can see I was referencing a lot of the Voron details, but this is relating to acceleration and jerk. And the acceleration, if I remember right, is just like it is in Repetier Marlin and the acceleration, and then I think the velocity is similar to jerk, but there's a mathematical formula to convert the jerk into that. Anyways, this is for X and Y. It's set to 250. I believe it's somewhere close to like the 8 or so that we had on the Repetier, maybe 10, and then the max acceleration of 1500. So yeah, these values could probably go up. It all depends on what your printer is sitting on, how good of an extruder you have, right? How good of a how tight your meld zone is. There's a whole bunch of different things here, but I think these are good values to start off with. Then we define the RepRap display. This is just a smart discount display. Nothing fancy there. In my case, I have case lights. If you've seen the pictures, it's the lights sitting towards the top. So those are the case lights. Again, I called it I know it's PC6 or AR31. And then I just called it output pin case light. And this case light is important because that's how you reference it later through G-code. Value 1 just means that when the machine turns on, the pin is set to high, which turns on the relay and turns on lights by default. So I always want the lights on when I turn the machine on, and then I can manually turn them off later. There really is no way to toggle this, which is really weird. You just set the pin case value to 1, or you set it to 0, and go from there. I have the M118 set up here. I haven't really cleaned this up, but really the M118 is just this respond. That's all you put in there, and all I use this for is debugging, because I want to make sure when I maybe print like similar to M117 that you print on the LCD screen, I want to print the same thing, whether it's printing, change filament, filament run out, sensor, whatever it is. I want to make sure that I have that in the G-code terminal as well, so I can see that. And then you can do other stuff with it too. So you can do commands, you can do errors, but for now I just use it in the echo. Runout sensor. So this is the filament runout sensor that I have towards the left of the printer. Probably move as I set up the printer again. But this is the configuration for it. You basically define a pause on runout to be true. And I'm still tweaking the G-code here. But you have to have this value, which means it's basically just going to pause when it runs out a filament. And then I have the runout G-code here. So I'm kind of still tweaking this a little bit, but basically wait for everything to finish. Any moves to finish. Sound the buzzer, which we'll talk about in a minute here. Show out of filament on the LCD. Show out of filament in the G-code terminal. And then we don't park the nozzle for now. Again, output to the terminal, and then we actually run a macro here called unload filament. So this unload filament will run, and we'll go over that in a second. So you want to be careful. This is where it gets kind of weird, because you don't want to do something that you would normally do as part of the unload filament. So you want to think about what you're going to do as part of that macro, and then just include it here in the run out portion, and only have the run out stuff here. Then it continues with that, and then we're already paused, so we don't need to pause again. I had this in there before, just testing. We dwell for 25 seconds, so this is really weird when you, whereas Repetier will, you can unload the filament, and then it'll turn off the heaters. It says turn off just the nozzle, and then you have to push the button, right, and it heats back the nozzle up, and then you can extrude, change the filament out, and then you push the button to continue again when you've loaded the filament. Klipper is a little weird in the sense that it has an insert G-code, so when you insert the filament in, it goes, and it runs whatever G-code you have here. So you have to be really careful, because obviously we're inserting into the run-out sensor, which in our case is still not the actual extruder, and unless you somehow have the run-out sensor built into the extruder, I don't really get what the point is of not having a default pause here. So I just put a wait of 25 seconds. So it allows me to load the filament through the run-out sensor, and then push it through the extruder, get it set up, and then it'll continue. So again, I'll output that, then it'll run the load filament G-code macro, which we'll talk about in a second. M118, M17, sound the buzzer, and it'll home the nozzle, which again, this is where that accuracy comes in the homing, right? So if you're resuming, you want to make sure you're resuming exactly the same spot. So far it's worked okay. And then you define which is the actual pin to set that. Now this gets a little weird. Sometimes you have to add the pull-up resistor, and then you have to reverse the pin. So you want to make sure that you're following the G-code commands in the wiki to test that run-out sensor and its value before you do any kind of printing. And just print something small and have fake filament loaded in there. Again, I'll go through probably more detail another time. This is just my notes. So pause, resume. I'm not quite sure yet if this is actually required or not. You can pause, but only when run out. You can pause Octoprint, but this is actually letting you pause Klipper itself. So it's a little weird because then Octoprint sends a pause message to Klipper. Klipper is the one that actually initiates the pause, remembering its values, and then when you resume, it's Klipper that is then resuming and then telling Octoprint to resume the print. It's a little weird, but the recovered velocity is how fast it moves back to the nozzle where it last was. So still playing around with this part. And then you actually have to create a custom beeper pin. I don't know why. It's not just part of the normal smart wrap discount. Most of these displays have beepers, but for whatever reason it's not part of the default code. So you do have to set this. You define it as PWM. In the case of smart wrap, you define the value as 0 when it turns on. Right? Obviously you don't want it beeping all the time unless this is flipped, which then you would just flip the pin. And then you have the cycle frequency, and then you have the PWM scale and frequency. So this is all just determining what the default tonal value is for that. If you muck with these values, you can get some weird sounding beeps. And then I just defined a G-code macro called M300. So I just run M300, and then it sets the default S parameter to 1000, the P parameter, which is the time, to 100, and then it runs this G-code. So a lot of times you'll see this within Klipper where some of the commands that we're used to in Repetier or Marlin, like M300, a couple of other mesh-specific ones or bed leveling ones, don't exist in Klipper. And so what people have done is just write G-code macros that then run the equivalent in Klipper as a macro. It works. This is all the start of the bed probe stuff. If you're not running a bed probe, you can skip this. This will depend on which carriage you're using, so that will differ every time. Again, the Z offset is commented out, which we'll talk about towards the end. And then you have the final speed here at the bottom. And then you have your Z-tilt compensation, right? So this is the Z-tilt for when the bed is like that, right? It'll lift the bed, and then it'll basically check the values with the probe, in my case 3 times, and then it'll then correct for that bed. So whereas with the mechanical, it'll just rise up, stop, this set will continue. With the probe, it'll probe to get those values and put it at the right tilt. So you need this Z-tilt. It's not bed tilt. That's something completely different. Do not use bed tilt, at least on the ENIAC, the way it's currently set up. You define the min-max positions, you define the points, You define how many samples you want to take. Sorry. You define how many sample points you want to take, and then it's going to do the average, and then how fast you're moving on the X and Y. Again, we can move pretty quick. You don't need you don't need exact XY accuracy between the moves, so we can move probably even faster than 200 here. And then for now, I did comment out the bed mesh configuration because it was just not working 100%, and I'm not sure what the issue is. And so just to remove bed mesh from the troubleshooting procedures, I just commented out. But this is very similar to the Z tilt. Your min max points, your probe counts. I think 3 to 5 is more than enough. No need to go crazy here. 1 sample because it's probing very slowly. And then the fade start and fade end, right? When it starts, when it will start to fade out the Z tilt, and then when it ends that Z compensation. When it starts the Z compensation, and when it stops that Z compensation. So that adjustment, right? So slowly it'll stop doing the Z compensation. This is the screw tilt adjust. I actually think this is pretty handy when you have a probe, which is then kind of weird because we have a probe and we have screws on the bed, but I like the idea of having a mechanically, a physically flat bed to start off with, and then probing from there. Just less mechanical moves, less having to rely on the firmware to do things. So all this does is basically define the 4 screws, what they're called, and then their 4 positions that are on the bed, right? And what it'll do is it'll move to each one of those steps. It'll take 3 samples, and between each move, it'll be moved 100. It'll take 3 samples, and it'll only keep the median, so it'll dump the outlier value, and then average the remaining 2. And then you have to put in the screw thread, and this is not the Z threading. This is the screw thread, the size of the screws that are holding up the bed. So in our case, they're M5s. They're clockwise. I don't know when you would use counterclockwise M5s, but they're clockwise. And so what's cool is it probes, and then it tells you turn, whatever, 90 degrees or 30 degrees clockwise or counterclockwise to get that value. And so you turn the front left one, 90 degrees. You turn the front right one 60 degrees, whatever it might be, and then you can run probe again, and then it just helps you make sure that you have a nice level bed. Again, this may even go away with the 3rd lead screw. Homing override in this case, because of the probe, we have to override the default. Override the default homing for Z only, right? We don't, X and Y is fine, like every other printer, but Z has to set absolute positions. It's going to move the bed down 5 millimeters. It's going to then it's going to home the bed at G28, right? Do X and Y, home X and Y, and then it's going to move to what is the center of the bed at 200 and 284. That basically just puts the probe itself at the center of the bed, and then it'll run the G28 Z0 like we normally know, which will lower or actually bring up the bed in this case towards the nozzle, and do the Z homing. You have to do Z homing in the middle of the bed. You can't do it on the sides. It's completely inaccurate, so you have to do the middle, which is why you have to do this homing override. This is where we get into some of the macros. So the recommendation with Klipper, and I like this approach, is that you use print start in your slicer's G-code, and then you actually have the starting G-code within Klipper itself. You can pass values to here as well, right? So you can pass temperatures, you can pass anything you want. Right now I just have it simply set to print start, and it does what I would normally do in my normal slicer settings for starting. And so we have the homing speed, the homing message. We home X and Y. We home Z0. Again, this probably could just change to G28. I'm still playing with this. Then we do the Z tilt adjust. We don't do the bed mesh calibrate anymore, and then we home again. It's just one of the quirks with the Z tilt adjust that you want to home again after. Then we move the nozzle down, and move the nozzle to the parking position, and then start the preheating process. Similar to the end G code, and I won't go through this in detail, but again, defining that end G code. We have an unloading filament G code, just to help with the unloading. A load filament G code here. There's a home and drop bed, right? So sometimes I might want to home and I want to drop the bed all the way down. That's what this will do. I have macro for on connect, where basically anytime I power off the printer, move it somewhere, I'm going to run the Z tilt adjust, right? I might do other stuff. I might do the bed screw compensation or calculation. I'll do the bed mesh calibration, right? All this stuff that I might do when I move the printer. And then the custom menu settings. Do not, whatever you do, modify the Clippy folder menu.cfg or something. Don't do that. That's the source of the code, and you'll likely break. You won't break a future update, but you will break whatever you change in there. Don't do that. You're supposed to, in the printer config, overwrite the existing menu, which is what I'm doing here. So the test menu, I've enabled it. Sorry, and it's not enabled. That's why it's set to false. So none of this other stuff really matters. Then I have a menu filament load, which runs the load filament command. I have menu filament unload, which runs the unload filament command. Prepare, right? And these are all the things that it does when it does the prepare. When you choose prepare in the menu, it'll give you all these values, and then you down here can actually define what those values are. So when you choose home and drop bed, it'll then drop down to here. It's a command. It makes sure that the toolhead is not printing. You won't want to do this while you're printing. And then you run the G-code home and drop bed. So this should always refer to macros. Should never have like long G-codes in here. Okay, and this is where the config gets interesting. So a lot of the calibration type routines, like bed mesh leveling, probe calculate, PID tuning, all these things are actually get set here in the config file. It's not like Smoothie where it sets an override file or somewhere else. It does overwrite the existing config file. It does save a backup and then overwrite it. And then it writes this config file down here. It says not to edit this, and you shouldn't edit this. But if, for example, you had to change your Z offset, what I've done in the past is I've changed it. I've commented this out by adding another hash or pound, and then write the Z offset up here. So you can do that if you want to tweak stuff. But remember, it's Z offset is here, and it's also in the very beginning under the Z stepper, but it's commented out there because this is the current value. So kind of try not to confuse things, right? If something is down here, that's the overwritten calculated value. If you have to temporarily play with it, just fix it like over here so it's close to it and you know what you're doing. Don't confuse things. Again, the bed mesh is still there even though there's no bed mesh. It has all the values there. And then the PID values for the extruder, the heater bed. Again, I probably have not done the PID tuning yet, which I should, but that's where it would be. So this is, remember, these were commented out before, and this is where they're actually valid. And that's it. So that completes the walkthrough Klipper, and we're almost at half an hour. Went into a lot more detail, and hopefully this helps people either running the ENIAC 40 or anybody else that's running Klipper on their machine. One thing that was introduced that I have not had time to do is set up separate configuration files. So you can have a configuration file that's the master file, and you just have some stuff in there, and then you have like child configuration files, which might be for like your steppers. There might be another one for anything that's bed probe or probe related. I'm going to definitely have another one that's just the macros. I'll have another one that's just the menu items. And so that's just a best practice to break it out that way, and then refer to them. So I still have to do that. It's not hard. You just move it out of the file and infer that file. But look for that coming soon. Other than that, I think Klipper's pretty awesome and easy to set up. And thank you for sticking around for half an hour. And don't forget to subscribe and like the video. Thank you.